Hello everyone, welcome back to the MP Coding Advanced C Programming tutorial series. In the last video, we looked at a simple overview of stack and heap memory. Today, let's go deeper into C pointers. So, what is a pointer really? A pointer is a variable that stores a memory address. That's it. Not magic, not referencing, not aliasing, just an address stored in memory. Let's understand this with a simple example. We declare an integer variable x and assign it to value 5. Then we declare a pointer p that stores the address of x. Now let's break down what happens in memory. The variable x lives somewhere in memory, let's say at address of hex 1000. The expression ampersand x means the address of x, which is hex 1000. So memory now looks like this. Now notice something important. The pointer p itself also has its own memory location. It is just a variable, whose value happens to be an address. So this is very important. A pointer is not the thing it points to. It is just a variable that stores an address. Okay, now let's understand what dereferencing means. The expression *p means take the value stored inside p, which is an address. Go to that address and access the value stored there. In our previous example, p stores the address of x. So when we write like this, we are going to that address. For example address, 0x1000, and overriding the value stored there. So this operation changes the value of x to 20. Now, let's do a simple exercise. Consider this code. We declare an integer variable x and assign it the value 5. Then we declare a pointer p that stores the address of x. Next, we declare another variable y and assign it the value obtained by dereferencing p. Finally, we change the value of y to 20. Now here are the questions. Does x change? Does *p change? Explain why. How many memory locations exist here? Is y connected to x? Pause the video here and try to answer these questions. Okay, let's reveal the answers to the questions. First, x does not change, and *p also does not change. Why is that? Because the statement y equals dereferencing p copies the value stored at the address of x, not the address itself. So after this line executes, memory looks like this. What does this mean? The variable x is stored at address 0x1000 with value 5. The pointer p is stored at another location, 0x2000, and it holds the address 0x1000. When we dereference p, we get the value at 0x1000, which is 5, and that value is copied into y. So now y has its own separate memory location with the value 5. Then we execute y equals 20. Now memory looks like this. What changed here? Only the value at address 0x3000 changed. That is the memory location of y. The value of x at address 0x1000 is still 5. The pointer p still holds the same address, 0x1000. Nothing touched address 0x1000. So to summarize, there are 3 separate memory locations here, one for x, one for p, and one for y. And most importantly, y is not connected to x. It only received a copy of the value, not a reference to the original variable. So here, the expression y equals to dereferencing p is equivalent to y equals x, because dereferencing p means go to the address stored in p and get the value there. In this case, p points to x, so dereferencing p gives us the value of x. But this is still copy by value. So y gets its own copy of the data, not a connection to x. Now, let's move to something powerful. Let's slightly change the code. Okay, let's understand what's happening here. We declare x and assign it the value 5. Then we declare a pointer p that stores the address of x. Now, this is the important part. We declare another pointer y and assign it the value of p. So y is not getting a copy of the value of x. Instead, it is getting a copy of the address stored in p. That means both P and Y are pointing to the same memory location, the address of X. Finally, when we write *y equals 20, we go to that shared address and modify the value stored there. This is very different from the last case. Now, answer these questions. Does X change? Does P change? Does Y change? How many memory locations exist? Can you draw the memory layout in your head? If you understand this properly, these questions introduce an important concept called pointer aliasing. So pause the video here and try to answer these questions. Okay, let's reveal the answers. Here, X does change, but P and Y do not change. Why? Because both P and Y store the same address, the address of X. They are just pointers holding that address. When we modify the value at that address, only X is affected. There are 3 memory locations here. One for X, one for P, which stores the address of X, and one for Y, which also stores the same address. This is what memory looks like before executing *y equals 20. What does this mean? Both P and Y are pointing to the same address, 0x1000. So they are both pointing to X. Now we execute *y equals 20. This means go to the address stored in Y, which is 0x1000, and overwrite the value there. So memory now looks like this. What changed here? Only the value at address 0x1000 changed. That is the location of X. Both P and Y still store the same address. So the key idea is this. P and Y are different variables, but they both point to the same memory location. 2 different pointers, but the same memory location. This is what we call pointer aliasing. This concept is the foundation of many important things in C, such as linked lists, trees, graphs, kernel drivers, and even embedded systems with memory-mapped registers. In fact, almost everything dynamic in C is built on this idea. And later in this series, I'll show you how to build a linked list from scratch. That's it for today's video. In the next video, we'll go deeper into pointer arithmetic. So stay tuned, and see you in the next video.